Hello everyone. Thank you for joining today's webinar. My name is JT Peterson and I'm the Director of Software Sales North America and the Head of Global Marketing here at ETA. In this webinar, ETA announces the release and immediate availability of Dynaform 6.2. Please join me as Ming Zhang, Senior Project Engineer, also providing Dynaform support, walks us through Dynaform 6.2's new features. Over to you, Ming.
Thank you, JT. First, I want to welcome everyone for joining our webinar today. My name is Ming Zhang. I'm the Technical Support Lead for Dynaform. Today, I'll present you the new features and the enhancement in Dynaform 6.2. Here is our outline today. We will start with the Dynaform background, and then we will go to the new features and the enhancement in 6.2. Dynaform is our flagship product for sheet metal stamping. It started as a small code developed for Ford Motor in 1983. The first version was released in 1996 with LS-Dyna as the core engine for predicting metal stamping deformation characteristic. Over the past 3 decades, multiple versions were released with many new technologies for solving sheet metal stamping problems. We have released version 6.1 last year. We are releasing version 6.2 today. Dynaform's market spectrum includes the following industry ranging from aerospace, automotive, and motorcycle to electrical and electronics. Basically, any industries involving development of sheet metal products are potential candidates for Dynaform. Dynaform consists of 6 distinctive modules. The blank size engineering module is widely utilized to unfold sheet metal products, nesting flat blank, and estimating blank cost. The formability simulation is equipped with LS-Dyna to perform various sheet metal forming simulation, such as deep drawing, line die, and the progressive die simulation. It also enables engineers to analyze springback and perform springback compensation. Die evaluation module aims to quickly evaluate draw die design through specially developed incremental solver, perform trimline evaluation and scrap size check. The blank and trimline development module enable engineers to conduct a near-net shape simulation to accurately predict the blank outline and trimline. Tube forming is carried out to perform numerical CNC tube bending simulation, preform, and hydroforming. Special tools are developed to allow engineers to automatically generate bending, preform, and hydroforming dies. Lastly, we have a die system analysis, which enables engineers to perform die structure integrity, scrap flow, and sheet metal transfer analysis. Next, I am going to present some new features implemented in version 6.2. I am excited to share with you all that the tube forming module is successfully implemented in version 6.2. It includes the following features: support complete process, rotary tube bending, preform, and hydroforming. Auto positioning of tube in hydroforming process. Combine part definition, tube die phase, and tube forming simulation. Support bend die design. Support preform and hydroforming tool design. As illustrated here, the tube forming application is included in Startup application. Tube forming fully supports tube bending, preform, hydroforming, laser cut, and annealing with tools for part definition, die face design, and setup of forming simulation. Here is the graphic interface of part definition, die face design, and the forming simulation setup. In part definition, users can define tubular product, start and end position of bending. Tipping function is also provided to rotate tubular product. Morphing tools allowed users to fill both ends of tubular product holes and perform boundary smooth operation. Lastly, the centerline calculation function utilized to automatically generate centerline for tubular products. This is product definition interface. After product definition, you can proceed to tipping operation. Next, performing morphing operation, for example, filling tube ends. Using centerline function, we can calculate or define tube centerline. Edit function is also available to modify centerline. Automatically generate the bending table with the centerline. Animate the feeding, rotation, and bending with the table. We can utilize tube bending table to automatically generate bend dies for rotary tube bending. After bending simulation, we can proceed to set up preform and hydroforming simulation. Preform tool enables engineers to generate tools to perform preform prior to hydroforming process. Support the die face design of hydroforming and create the hydroforming tools for both upper and lower. After part definition, we can use die face functions to define tubular hydroforming die face. The end extend function is provided to extend the both ends of tubular product to initial tube size. The separate tools functions are provided to split upper and lower hydroforming die face. We can split die face using a defined angle. For tube bending simulation, two options are provided. The first option allows us to generate bending result using one-step approach. The other option is generating bending results using incremental simulation. Once setup is complete, the job can be submitted using Job Submitter. You may choose either SMP or MPP as Dyna solver to run bending, preform, and hydroforming simulation. After the simulation is complete, we can use results to post-process forming results. Here is the result comparison of one step and the incremental bending. In Dynaform 6.2, we also enhanced the nesting capabilities of BSE. The edge with calculation method is improved. As a result, the calculation of material utilization is improved. By using arc to offset shape corner, the material utilization is further improved. Limited coil width is considered in new nesting algorithm and resulted in significant improvement of material utilization. The algorithm of multi-row nesting is enhanced and resulted in improvement of material utilization. Lastly, the single row option is provided in mirror nesting. It resulted significant improvement of material utilization. We have also improved the blank and trimline development module by implementing automatically repositioning of guide pins during optimization process. The guide pins are positioned to the updated initial blank outline. A couple of enhancements are implemented in Geometry Manager. Here, the new layer and add to this layer functions are implemented in curve operation. It enables us to edit the imported curves. The spread option is implemented in surface selection. We can define spread angle to select surfaces. In results, two options are added in contour function: label value and label nodes element value curve. We can display contour values of selected nodes and elements. If a label node element value curve option is selected, we can plot the graph of selected node and element. We can click right mouse button to edit the contour setting. Last, we have improved the interface of processing result in ETA report. That's all for my presentation about the new features and the enhancement in Dynaform 6.2. Again, thank you very much for joining our webinar today. If you have any question or if you want to know more about 6.2, please visit our website at eta.com or send email at info@eta.com. Thank you very much and have a great day.